Today I will explain about 1.3 subsets, supersets and power sets. So let me go to the full screen so that it is going to be better. So now here we have. So now this is 1.3 of unit 1 and this is heading subsets, supersets and power sets. Okay, about these three topics we are going to study today. So what are these things? The first I can write down here 1.3.1. okay, let me select another color. Blue, it will be better. So now here 1.3, that is subsets and supersets. Okay, subsets and supersets. So now what are subsets and supersets? So first here by giving example I will explain you. Here set A, if given 1 comma 2 comma 3, this is set A, and set B if given it's like 1 2 3 4 5 and 7. Okay, so now you can see A is a subset of B. Okay, why? Because each element of A, now you can see each element of A meaning 1 2 3, these all three belong to set B also, so that's why set A is a subset of set B. So if each element of the set belong to any other set, then we say that the first set is the subset of another set. So here you can see 1 here, it is 2 also here, and 3 also. So these all three elements are also present in B, so that's why we can say A is a subset of B, and that can be denoted by this symbol. Okay, this is the notation, this is the symbol we use for subset. Okay, so here we can say A is included in B, or B include, or in other word we can say that B includes A, means inside B A is present. Okay, so this part is A. Okay, or in other words, so here A is a subset of B, we can say, or in other word we can say B is a super. Now where it went? Yes, so here in other word we can also say this is for subset. Okay, this is what? For subset. Or in other way also we can write down, if B is a superset. Okay, if A is a subset of B, then we can say also that B is a superset of A. Okay, so and superset is denoted by this symbol. So this is the symbol for superset. Okay, there I think it is problem in the system, but yet I will try to explain. And if you see here, so if here it is subset and superset, if each element of A belong to B, then in that case that is a subset. Okay, and now you can say here, if all element of A belong to B, and all element of B also belong to A, or you can say if every element of A is in B and every element of B is in A also, then we can say that we can conclude here that A equals B. Okay, and if A is not a subset, so here in this case we can give example of A as 1, 2, 3, and set B we can also write down 3, 2, 1. Now you can see each element of A is in B and each element of B also present in A, so that's why A and B are equal. And if A is not a subset of B, okay, for example, if A equals 1, 2, 3 and B equals 4, 5, 6, so now here A is not a subset of B, so we represent this one by this symbol. Now next come to the proper set. Okay, now where we were, now here, go to the full screen. Yes, now next here, what is proper subset. Okay, what is proper subset? By giving example I will explain. So here by giving example here, now you can see if A comma 2, 3, set A, this one A, and another set B, okay, cross this one, another set B is equal 1 comma 2 comma 3 comma 4. Okay, so that much. Why is such problem it is coming? Why it is moving again and again? Now here we go. So now in this case A is a proper subset. Okay, and the symbol for proper subset, you can see all element of A present in B but all element of B not present in A. So 1, 2, 3 are in B also, so here we can write it like this: proper subset A is a proper subset of B. This is the symbol for proper subset. Okay, why problem it is coming? Okay, so that's it is about proper subset. So graphic means here by using a figure also we can understand. Now you see this is set A. Okay, this is set A another one it is B. So you can see here, since A is present, this one it is A, okay, this is A is present in B, so that's why A is a proper subset of B. So why here it is happening? Now you can see 4 belongs to B, but 4 doesn't belong to A. So this, due to this reason, A is a proper subset of B. Okay, and now next what is given? Universal so here in this graph, first of all, let's like 1 2 3 okay, and 4 it is outside of. Now next here it is given universal set. Universal set, what is this? What is universal set? So universal set is denoted by capital U. So universal set is a set in which elements of all possible sets are there. For example, if A, so if two possible sets are there, it's like 1, 2, 3, and another possible set, if only two sets are possible, it's like 2, 3, 4, 5, then in that case, two possible sets, then universal set U will contain all elements of A and B. It's like 1, 2, 3, 4, 5. So only two sets are possible here. I am assuming here that only two sets are possible. So due to only two possibilities here, we can consider that elements 1, 2, 3, and here in set B elements are 2, 3, 4, 5. So universal set will contain all elements of set A as well as the elements of set B. So that's why this is universal set. Now next come to the power set. What is power set? So power set, it is nothing but the set of all subsets. For example, by example it will be better. For example, if X is a set, X is set just like 2, 3. So subset of this set X will be, okay, so subsets here we can write. Subsets of this set X will be 2, then second subset it will be 3, then third it will be 2, 3, and fourth it will be 5, because empty set it will be always in all set. So these are subsets, and and now here what we can say, set of all subsets. So here if we write down set of all subsets, set of all subsets, set of all subsets. So now these are all subsets, so I can start with this, because we always write a curly bracket for writing set. So the first subset it is 2, second subset it is 3, third subset it is 2 comma 3, fourth subset it is 5. So this is power set. Okay, so we can denote this by P or here X. So this is power set of X equals, we can write down here the set. It's like here set A. What it is? This is set A, and here A belongs, A is a proper subset of X. Okay. Now here A is a subset of X. So A is a subset. So in this way we can get power set of any set. Another example I think I should give so that you can understand in a better way how the just like any set I'm writing. Okay, A equals a set, it is 1 2 3. Okay, so subsets, all subsets of set A will be 1, then second subset it is 1 comma 2, third subset it is 2 comma 3, and third subset it is 1 comma 2 comma 3. So now you can count 1 2 3 4, and so 1, then after we can write down 2 individually, then 3 individually. So 1 2 3 4 5 6. So 1 2 3 already completed, then 1 comma 3 we can also write 1 comma 3 4 5 6 7, and then after 1 it is 5. Always keep in mind whatever it is the number of the element, no? So 2 to the power that number n, 2 to the power n will be the number of subset. So if 3 elements, so we can write down 2 to the power 3, it means 8. It means total 8 subsets should be there. For example, here 1 2 3 4, here you can see 1 2 3 4 5 6 7 8, total 8 subsets are there. Okay, so the power set of A, so power set of A we can write like this. Power set of A, set of all this, just like here I can write down 1 1 comma 2 2 comma 3 1 comma 2 comma 3, then after there it is 2 also, then after 3, then after 1 comma 3, and then here 5. So this all, why such problems are coming? So this is the power subset, sorry, power sets. the power set. That is all about this. Now in the next class I will explain 1.4 operations on set. What are different operations possible on set.